Okay, today I'm going to talk about the key ideas in correlational research. So, what is the purpose of correlational research? Its job is to show a relationship between two separate variables. It does not show cause and effect. Remember, the only thing that can show cause and effect is an experiment. All correlation does is show that there's a relationship between two things. So correlation does not equal causation. That's a really important phrase in psychology. Here's two examples of things that are correlated. So the first one is number of people who drowned by falling into a pool correlates with films Nicolas Cage has appeared in. Does that mean that if Nicolas Cage is in more movies that more people are going to drown in pools? No. All it means is that those things are correlated. So you can see like in 2000, 2001, they're very closely correlated. And then as his movies increased in 2007, so did the number of drownings. It does not mean that one thing causes the other thing. You can see here the correlational coefficient is 0.66. We'll come back to that number later. Here's another example of two things that are correlated. Per capita, that means per person consumption of mozzarella cheese, is correlated with civil engineering doctorates. Does that mean if you eat more cheese, you're going to get a civil engineering doctorate? No, it just means that they happen to be correlated. When one goes up, so does another one. So you can see the correlation coefficient for this one is an even higher number, which means it's even more closely correlated. And if you look back at the previous graph, you can see there's a little bit more of a separation with some of the lines, and then these ones are more closely aligned. That means that their correlational coefficient is going to be a higher number. Again, we'll come back to that at the end. So, correlation does not equal causation. Here's another example. Low self-esteem is linked with depression. When self-esteem increases, depression decreases. Does that mean that depression causes low self-esteem? No, it just means that they're related. Low self-esteem could cause depression. Depression could cause low self-esteem, or it could be some other event that causes both low self-esteem and depression. So I'm going to say it again. Just because two things are related does not mean that one thing causes another thing. Correlation just shows relationships. So let's talk about the different types of correlation. You have a positive correlation, a negative correlation, and then no correlation. This is a graph of a positive correlation. What this means is when one thing increases, so does the other thing. So for example, study time and GPA. As study time increases, so does your GPA. That's something that's positively correlated. Something else that would be positively correlated could be exercise and muscle mass. So the more that somebody exercises and lifts weights, their muscle mass is going to increase. That's something that's positively correlated. And remember in class, if you put your thumbs up when one thing goes up and then put your other thumb up when something else goes up, that means it's a positive correlation. On the other hand, a negative correlation is when one thing increases, the other thing decreases. So there's still a correlation, it's just a negative one. So remember in class we talked about as years married increases, amount of hair decreases. That's a negative correlation. Does that mean that being married is going to cause you to lose your hair? No. There's a third factor, which in this case is age. As you age, you tend to lose more hair. Then you have this third option, which is no correlation. So two things that just have no relationship whatsoever. Some of you found this when you did your survey, that your two items that you thought might show a relationship did not in fact have a relationship. So a correlation coefficient is the measure of the strength and direction of a relationship. What does that mean? So they use the symbol r, lowercase r, for the correlation coefficient. And you're going to have a number of a range between -1 to +1. The closer the number is to 1, either on the negative side or the positive one, the stronger the relationship is. And then if the number is positive or negative, that tells you what type of correlation it is. So for example, R equals positive 0.37, that means it's a positive correlation, but not a very strong positive correlation. We'd say that that was a weak positive correlation, as opposed to something like positive 0.95, which was the per capita consumption of cheese versus civil engineering degrees that we looked at before. That one is a much stronger relationship. So if you had a negative number, a negative correlation like negative 0.98, that would be a stronger relationship than this one that's shown right here, positive 0.37. So whether it's positive or negative doesn't show strength. It just shows if it's a positive correlation or a negative correlation.